We're back again with the Coleman KT196 Gokart. As the title states, we'll be adding electric start to this thing and at the same time opening the engine up so we can remove the governor hardware and adding a timing advance key when we put the flywheel on for the electric start. To do all this, I'm obviously going to have to remove the engine so I can more easily work all around this thing. Removing the engine is pretty simple. Just removing the carburetor and any associated linkages, removing the torque converter belt, since the torque converter is actually two separate portions instead of a whole fixed unit, and removing the 4 bolts that secure the engine to the plate on the back of the go-kart. With all that said and done, I'll be able to get this engine out and on the table where we can go ahead and open this thing up. Okay, for future reference, removing an engine from a KT196 is kind of a pain in the butt. There's 3 regular nuts and bolts, and then there's a stud right here that has like a 13mm bolt on it. The rest are 12mm nuts with a 10mm bolt head. And trying to get underneath here with ratchets and all that, it's really a pain. But I had to get those 3 off first and then turn the engine to get enough room to be able to get a wrench onto the nut to remove that thing. But with our engine off, we could go ahead and put that thing on the stand, or on the table more accurately, and get to work. First thing we need to do is drain the oil from the crankcase so when we do pull off the crankcase cover, we won't have a hot mess on our hands. The next thing we'll do is pull off the torque converter clutch so we can be able to pull off the crankcase cover, and then with our exposing of that component, we can then get a peek inside to see all of our governor hardware. Now we'll go ahead and pull off the pull cord assembly and the cover from around the flywheel, and then using our impact wrench and a 19mm socket, we'll remove the nut off the flywheel and remove that hardware. Then we'll go ahead and put the nut back on, ensuring that the edge of the nut and the edge of the threaded portion of the crankshaft are flush, and then using a large flathead screwdriver as a lever and a small sledgehammer, give light taps to the flywheel, well, to the nut, and try to knock the flywheel loose off of the tapered shaft. Of course, wrapping the crap out of a crankshaft with a small sledgehammer is going to cause some other items to come loose, namely our valve train components, but that's no big deal. We'll get all that stuff back together. It's just less stuff for me to have to remove so I can get in here a little bit better to get our governor hardware out. But first thing I have to do is remove this lever right here that's connected to the shaft going into there, and then go ahead and remove the retaining clip holding the lever in place. From there, use the die grinder to cut the exposed portion of the lever free, and then tap the remaining lever body into the crankcase to facilitate its removal. From there, we'll go on to the other side of the crankcase where the shaft holding the governor gear is pressed in, and just tap that into the crankcase just as well, and be able to effectively remove the entire governor gear, leaving us with a couple of empty holes in the crankcase. The way we'll be addressing our 2 empty holes in the crankcase is by cutting them with a 1/4-inch tap. I'll be using a rag inside the crankcase to catch the shavings generated from cutting those treads, so that material does not present itself as a problem later on when the engine's running. From there, the bolt going into the top hole where the lever was at will be applied from the outside in, and the bolt for the side hole where the governor gear shaft was at will be applied from the inside going out, so the bolt head will not be obstructing our flywheel when we reassemble all that hardware. At this time, it would be good to inspect your camshaft to ensure that the decompression mechanism is free of any kind of debris, so you won't have any problems in the future with a pull cord getting yanked out of your hand when you try to start your Predator 212 or similar engine. There should not be any kind of garbage in here. This whole thing should be able to freely move around. So with that, I'll go ahead and reassemble this thing. To reassemble all your valve train components, you're going to want to start off by putting your little lifter pieces back in place first. Then you should have your crankshaft set the top dead center, because you need to make note of that timing mark right there. And of course on the camshaft, make note of the timing mark there. And you'll be able to mesh these two components together, get that camshaft seated, and the dots should line up. Camshaft should be nice and seated in its spot right there. Now with that, I can go ahead and put our push rods in and set the valve lash. As for our push rods, pretty straightforward. Just insert them into the passageway there, get them seated in the lifter, and then go ahead and reseat the rocker arms. Go ahead and give the retaining nuts just a light tightening, not even hand tight, because you'll have to set the valve lash. Now Google says that the intake should be set between 4 and 6 thousandths, and the exhaust should be set between 6 and 8 thousandths, so we'll go off of that right now. I know there's people out there that have their own measurements for setting valve lash based on what they do to their engines, but we're going off of a baseline here since we're really not doing too much of anything above stock anyway. But I am going to go with the smallest of that range. So in our case with the intake, we'll be going with 4 thousandths. Just a simple matter of putting that feeler gauge in there and tightening that nut enough to where you have some resistance, but it's not snug. And then from there you can go ahead and tighten that down. In our case, this engine, the main nut is 14 millimeter, and our little retainers are 10 millimeter. So I can go ahead and tighten that down if the dang thing will let me. We'll have to loosen that up a little bit because, well, had some play going on. So go back. We have a little bit of lash there. Now we go ahead and snug it down. Probably more like 3 thousandths of an inch, but we can go with that because there is some play in there. Next we'll go with the exhaust. We're doing 6 thousandths on that one. Same deal. Got a little bit of resistance there. Go ahead and hold that down, and so now we're set on that. We should be ready to go. Good thing about these engines is you can always go back in there real easily to readjust things if need be. So go ahead, snap the cover back on here, and then we can move on to the main event, which is the electric start hardware. Let's not forget to put our side cover back on. Luckily our gasket was still pretty intact, so I could reuse this thing. Go ahead and get this thing situated, and then go ahead and put our side cover back on carefully so I don't damage the bearing. Put that sucker on there. Make sure the camshaft gets seated inside. And we are locked down like so. Google says that the torque specs for these bolts is 17 foot-pounds, so I'm going to go ahead and get those on there, and then we're going to move on to, as stated, our main event, electric start. We're pretty much going to be installing a fair part of our electric start hardware before we even bother with the timing advance key. The first thing we're going to install is our charging coil, which is held in place with a couple of bolts on the bottom right here. Route the wire out of the way. Once that's all said and done, we can move on to installing our starter. There's a bushing that has to be installed in the hole right here, and once we lock the two bolts down and hold the starter in place, we have to add these couple of brackets right here just the same. Once that's all said and done, we can move on to our flywheel. To do the flywheel, use some valve grinding compound to lap the surfaces, which is just a simple polishing where we put the compound on the shaft, put the flywheel on there, and rotate the flywheel back and forth a little bit to polish the metal surfaces. Afterwards, we'll pull the flywheel off, wipe the stuff off of the crankshaft and the flywheel, and then we can go ahead and install our timing advance key. Our advanced flywheel key is installed pretty much the same as a regular flywheel key. It's just pressed in, and sometimes you have to tap it in to get it to seat itself on the groove on the crankshaft. But with the lapping all done, key in place, also make sure you put it in the right direction because you need the clock in advance. But with all this done, I can go ahead and get our flywheel installed. We have a tool made out of the components from an old centrifugal clutch, and really just the base that's inserted on the crankshaft, and there's a couple extra grooves carved into it in order to allow me to lock the thing down with the mounting holes on the crankcase. But with that locked down, our flywheel is unable to move. So now, according to Google, the flywheel bolt is torqued down to 55 foot-pounds. So I'm gonna go ahead and snug that sucker down and go ahead and start buttoning this thing up. Google states that the coil gap for a Predator 212 is between 16 thousandths and 40 thousandths of an inch. Now, using a feeler gauge, after I put everything on here, using a feeler gauge, the one that actually fits in here ends up being 18 thousandths of an inch. So I would actually have to say that our coil gap is within spec for this thing as far as stock components. So with that all said and done, we can go ahead and start getting the rest of this stuff buttoned up and get this thing back on the go-kart and get the electrical aspects of this thing done. As for completing our electrical system, we're going to be focusing around this box right here that came with the electric start kit. This would normally be bolted up to the side of the engine, but because we want to try to set our go-kart up to be more car-like, this is going to be located remotely, in our case, where the dash area is at, which means I'm going to have to splice a bunch of wires in between this box and the engine. But I'll be starting off by securing this box to the framework of the go-kart with some self-tapping screws to ensure that this thing's not going to go flopping all over the place, which means besides a single screw in the mounting tab on the box, I'm going to have to poke another hole through the bracket and into the frame so we could have two mounting points. The first pair of wires that we're going to take care of are our basic cutoff wires, the ones that would normally go to that toggle switch and link up between the oil pressure switch and the ignition coil. More or less, it's just simply a switched ground to kill power to the ignition coil so the engine can shut off. We have two wires right here going to our switch box, and we have the wire, the pair of wires in that cable going to our switch. All we're going to do here is just simply cut this wire and then splice the remaining end into these wires right here after cutting these ends off. That way we can have a nicely spliced pair of wires, blending the old with the new. Our next wire that we're going to do is our charging coil wire, this brown wire. I'm going to cut the end off of this wire so I could splice it to our longer length of wire at the back, and then route that wire along the channel on the floor up to the front where our switch box is at, and then splice the switch box wire in with that brown wire, thereby completing our circuit. The last pair of wires we have to address are the wires going to the starter and the starter solenoid. This white one here with the loop goes on to a bare terminal on the back of the starter, and this one plugs up to the wire going to the starter relay. As we can see right here, that's for that white wire, and this one's for the black and white going to the starter relay. I'll go ahead and route some more wires through our little trough coming up through the back behind the seat there, and get those wires terminated at our starter so we could wrap that part up. And then lastly, we'll be adding the main power wires going to our battery. Okay, temporarily I'm utilizing this lithium battery that I set up to act as a standalone power pack for other applications, hence why there's a 12-volt receptacle there, but never mind that. Anyway, I got to strap this thing down too before I actually test drive it, but for right now, we have our power wires hooked up. The positive wire is hooked up to that same lug that that black and white wire was hooked up to on the starter, and the black wire is going to a ground point on the engine block, and the wires are routed up nice and neat with zip ties up to the point where our battery is at. So with that all said and done, we should be able to crank this thing. There's a bit of confusion regarding the two wires going to the switch box for this starting kit. Online schematics and other testimonies say that these two wires are supposed to just be a simple switch link between the oil cutoff and the coil on a normal Predator 212 or similar engine. Basically, the switch just grounds out the circuit when you want to turn the car off or turn the Gokart off. In our case, putting a meter on these wires, this thing is staying on between these two wires. We got continuity all the time. So because of that, can't start this thing up. So to keep things simple and not have to dig too deep into this, I just went ahead and removed the connections from these wires going to the switch box and connected them back to the original wires going to our square switch on the panel right there, so we could just turn the thing on and off like normal and just use the switch box for actually starting the engine. So with that, I'm going to go back and try to start this thing again. She starts right up with the starter. Like usually I have to finagle with this thing, but yeah, the starter starts the thing. So I guess at this point I'll go ahead and secure this battery and take this thing for a little spin. Stand by. Well, that was fun. Even with the addition of our electric start setup, whenever I have to persuade this little engine to start up, I could at least do so without throwing my shoulder out. I could just sit myself comfortably in the seat and feather the pedal and the choke and get this little engine fired up and ready to rock and roll. With the addition of the advanced timing key and removing the governor internals so this thing doesn't eventually puke its guts out from revving too high, this little engine was able to launch this go-kart forward pretty good and be able to get us a little sideways action too on the grass and the gravel. And if you're not careful driving this thing, you will go sideways. But as is the case with this type of stuff, we're not really done with this. I'm sure I'm going to find more stuff to do to this little go-kart that's going to make it even more sketchy and dangerous and henceforth fun. But for now, we're going to leave it off here. And because the weather is still kind of meh, we're going to go ahead and put this little thing back under cover here so it can be protected. And we're going to also put ourselves back under cover so we can be protected and plan our next move with all this stuff. So until the next time, as usual, hit the like button because likes are free. Subscribe if you hadn't already. Check out TikTok and YouTube shorts, all that good stuff, website and everything. And stay tuned for more go-kart and small engine motorsports craziness as we continue to get a little braver and try even more stuff and get up there with the big boys when it comes to some of this stuff. That would be a good ambition. Try to maybe throw a turbo on this thing, perhaps, or something to make this thing be even faster. Who knows? Whatever. I'm done. I'm going inside. Give me a drink. I'll catch you later. I'm out.